In this video, we'll start to learn about organic reactions. There are a few different types of organic reactions. First, we have addition reactions. That's where we have two reagents combining together to form a single product. And when this happens, there's typically no leftover atoms. So example, if we had ethylene, which is just 2 and hydrobromic acid. These two will react together in an addition reaction. Where the HBr is added to our molecule. And so we go from ethylene, an alkene functional group, to bromoethane, an alkyl halide. So you can see during the course of the reaction, we end up changing the functional groups. We go from an alkene to an alkyl bromide in this case, through an addition reaction. The opposite reaction can occur as well, which is an elimination reaction. And that's where a single reagent will split into 2 or more products. So if we start with that same bromoethane, and we add a base in, we can get the reverse reaction to occur. We can get that elimination to occur. And so we go from our alkyl bromide back to our alkene. And in this case, we end up forming these 2 products. A third type of reaction is called a substitution reaction. And this is where 2 reactants come together and they'll exchange parts of each other to form 2 new products. So let's say we have methanol. And HCl. Those 2 react together and go through a substitution reaction, where the OH, that alcohol, gets replaced by the chlorine. So here we went from an alcohol to an alkyl halide. We can see what happened is this OH group and the chlorine, they swapped places. So they did a substitution on the carbon. Went from OH to a Cl, we substituted what that functional group was. And our fourth type of reaction is what we call a rearrangement reaction. So this is where we have a single reactant, and it's going to yield an isomeric product through a rearrangement of its bonds and atoms. For example, let's say we have 1-butene. And I add an acid catalyst. We don't really care about which type of catalyst, just as long as it's an acid catalyst for the moment. What will happen is the atoms and that double bond will rearrange. So it'll go from the 1 position to the 2 position. So we end up going from 1 butene, where that double bond is going between carbons 1 and carbon 2. So now that double bond's going between carbons 2 and carbon 3. So we end up with 2 butene. And even though this is an acid catalyzed reaction, it is reversible, but that 2 butene is a more favored conformation. And we'll start to learn why that's a more favored conformation later on. So these are 4 different categories of organic reactions you should really keep in mind. We have our addition reaction, elimination reaction, substitution, and rearrangement. Across these 4 categories, we'll see a lot of different organic compounds. So now looking at those reactions in a little more detail and looking at the reaction mechanism. So what the reaction mechanism is it's an overall description of a reaction process. So how does that reaction actually occur? Reactions occur in a defined step that can lead from reactant to product. So we should be able to easily see how you went from the reactant to the product. And it must account for all reactants and products. You can't just randomly throw things out or randomly have things appear. What'll happen is it's a chemical reaction that involves breaking bonds and making bonds. So if we had that double bond back to our ethylene example, and it reacted with that HBr, you should be able to tell me step by step how these two react together to form that product. If you can't show step by step how it reacts together, then you may not know all the details about this reaction that you should. So if we think about it, and what will happen is the electrons from the double bond are going to come and attack the hydrogen. So since the double bond is doing the attacking, the double bond is your nucleophile. Remember that term from back in the beginning? Here's where it starts to come back a little bit. And then what will happen is the electrons from the bond on HBr will go directly on the bromine. That gives us so these two would be considered intermediates in the course of the reaction. So you can see we started with our ethylene and our HBr. I showed the flow of electrons on how I got to my intermediates. Now I need to show the flow of electrons on how to get to the product. Since our bromine has a negative charge, it's going to become a nucleophile and attack the carbon that has a positive charge, or what we call our carbocation. And so when it does that, I end up with the bromoethane product. So you can see in the course of this, I showed all the steps for the electron flow between all the different reactants and intermediates to give me my product. I used up everything in the course of that reaction, and I came out with just the product I need. There's no extra products or extra atoms floating around. This would be how you'd start to think about writing reaction mechanisms. Show that flow of electrons from each of the species. Also, don't try to add too many arrows into one step of your reaction mechanism. Sometimes it's better to break it down into little bits and just write it more steps than to try and cram everything into one step. And so there's a lot of detail within our reaction mechanism. With those arrows that I draw very specific arrows for very specific reasons. And what it's doing is it's showing the bond change. We can have two types of bond changes. We can either make bonds or break bonds. And when we do that, they can either be symmetrical or unsymmetrical. Symmetrical cleavages are called homolytic cleavages. Unsymmetrical are called heterolytic. And depending on which type of cleavage you're doing, you'll use a different type of arrow. If it's a homolytic cleavage, you use a half arrow and you show one electron going to each of the atoms. So this is our symmetrical bond breaking, which is typical of radical reactions. And we'll learn more about that in just a minute. And that's where one bonding electron will stay with each product. The unsymmetrical bonding, the heterolytic cleavage, is similar to the one I just showed you, and that would be considered a polar reaction. And that's where the two electrons stay with just one of the products. And we can have the same thing with bond formation. If I have a symmetrical bond formation, each atom will donate one electron to form a new bond. If it's unsymmetrical, one atom will donate two electrons. One atom will donate its lone pair to form the bond. And so you can see the shape of the arrows are a little bit different. That's when we talk about our types of arrows. If we use a half head or fishhook arrow, that involves just one electron because we only drew half arrow. You can think of the full arrows like two electrons, one on each side. If only one electron moves, you draw a half arrow. If both electrons are moving as a pair, you draw a full arrow. So that'd be the difference of having something like that versus showing a full arrow. Showing the half arrow tells me only one electron is moving. Having the full arrow shows me both electrons are moving. And so what I don't want to see from people is if we have our compound here and you try and draw something like that, where it's two full head arrows, when you're really trying to explain a radical reaction. If you draw the two full arrows, that's saying that the electron pair is going to both atoms, which is telling me you have two electron pairs. You have 4 electrons total when you only drew 2. So don't do that. Also, don't draw a half arrow when you really mean an electron pair is moving. A couple things to keep in mind before we really get into our mechanisms. So as I said, our types of reactions. We have our categories with addition, elimination, substitution, rearrangement. This category, our types of reactions, explains how the electrons are moving in the reaction and in the mechanism. The other ones kind of give me reactant to product. Here, if I'm trying to decide between a radical reaction and a polar reaction, that tells me how the electrons are moving to get from that reactant to that product. So in a radical reaction, that's where we have the symmetrical bond breaking. That's where we use the half arrows. It's where we use our fishhook arrows. In a polar reaction, that's where it's the unsymmetrical bond breaking. That's where we move electron pairs. And we use the full arrow. Most of the time, most reactions go through polar reactions. So most of our reactions tend to be polar reactions, and you tend to use the full arrow. Only occasionally will we see radical reactions. And in those radical reactions, we have what we call a radical. And that's a neutral chemical species that contains an odd number of electrons. So it usually has a single unpaired electron in one of its orbitals. And that unpaired electron is what is used when you go through the mechanism. And so now we've learned our 4 different categories of reactions. And then we've also learned the 2 different types of mechanisms we go through, radical and polar. And we'll see these 2 types of mechanisms in the next videos.